Okay, so in this video, we're going to talk a brief introduction about Tinkercad. What I'm going to do is just make a circuit that basically turns on an LED using a battery and an LED. There's nothing going to be really special about it, but I just want to show you the interface and how it works. So I've already logged in, and you can log in with a number of different options. You can log in with a Gmail account if you want to not sign up for a new account. You can make an Autodesk account. You have a bunch of different options. I've personally logged in with my Gmail. I don't really want to make a new account, and Tinkercad has no issue with that. It's free for everyone to use, so I would recommend going ahead and doing that. Tinkercad actually has a number of different options you can use to design things, and the first one that's always selected is 3D designs. It's actually quite fully featured. It's closer to a SketchUp than a SolidWorks, though, so it's going to have not really the full-featured 3D modeling that you're expecting from a SolidWorks, but it's sufficient for 3D printing, so it's pretty good. But what I'm going to do actually for this entire course, we're only going to be using the circuits part, so we're going to click on circuits. And what you'll notice is it makes actually a bunch of names for you. So these are circuits I've been building as I've been writing labs for various courses. It has things like Arduino, so we won't be using that in MTE 120, but in different courses we do. And you have a bunch of other circuits I've just been playing around with. And so what I'm going to do is create a new circuit and then build the LED. So I click on Create a New Circuit, and it'll load its interface. And what it's going to do is give me a number of the circuit elements, which are on this side here, and then a blank canvas, essentially, where I can start making my circuit. You'll also notice that it sort of makes up names for things. So I'm going to, the first thing I do always is, well, hopefully try to rename that circuit. So I'm going to go ahead and name it, LED basic or something like that. Doesn't really matter. Because Tinkercad will save things for you, I'd recommend very strongly saving things with names that make sense to you. So for instance, you might call it, Lab 1, Circuit 1. And so when you have to go back to it and try to figure it out and rebuild and everything else, you can use that rather than wondering whether it was some random name that Tinkercad made up and whether that was the right circuit or not. The next thing is it always starts with only the basic components showing. There's another tab, I guess, called All, and you can do that as well. For the most part, it's up to you which one you want to use. For MTE 120, the basic circuits will take us pretty far, but for the most part, what I tend to do is just always go to All, and that way I'm not searching for circuits that may not be in the right tab. So to build any circuit, the first thing you always start with is a breadboard. So I'm going to search for a breadboard. You can also scroll down and you'll see actually you can find them if you scroll down far enough, but I just want to show you how to search as well. So there are the breadboards, but let's go back to the top. Let's pretend as though I didn't know that. I didn't want to search through it, and I would type breadboard or bread, and these things come up here. Which size you use is sort of up to you. As long as the breadboard is large enough for your circuit, it really doesn't matter. Just don't use the mini one unless you really mean to. The reason for that, and you went through this in the breadboard lab actually, is because the mini one doesn't have the rails, whereas these two do, the regular one and the small one do. So I would recommend only using these two, but realistically, as long as the circuit gets built, we don't really care too much in this course. So I'm going to take just a large breadboard. So I clicked on it, and it sort of takes a little while to show up. There it goes. This is all web-based, so it does take a bit of time. And then I can sort of place it wherever I want to. And I'll place it here for now. So I just have to click on that, and it'll place it. I can name it if I want to. I tend not to name my components unless you're making a very large circuit. So I'm going to not name it. I'll just click away from that. If you want to move around, I can click the middle mouse button and sort of scroll around the circuit. Again, when the circuits get a lot larger, you can go ahead and do that. Now, the next thing, when you're building any circuit, what you're going to want to do is make it so that you build the circuit components unpowered first and then power it. Now, in Tinkercad, it really doesn't matter. I mean, if you blow up a simulated LED, whatever, you just reset and try again. But when you're building real circuits, if you try to connect power first and something goes wrong, you might end up shorting your actual power supply itself. And so you might end up, blowing up a power supply or whatever it happens to be. And so it's always a good idea to start with components first and then power them. And that's why the rails are so important, which are here. So what I'm going to do is let's put an LED in. So instead of searching for breadboards, I'm going to search for LEDs. So I type in LED, and you'll notice it pops up with a number of options. They have all these really cool NeoPixel things and all that sort of stuff. I just want the regular LED here. One interesting thing about LEDs is they have a long leg and a short leg, and it's actually, in Tinkercad, it does show you the longer leg is the bent one. So this is the leg that is connected to the higher voltage, and this one must be to lower voltage if you're going to have the LED light up. The one downside to Tinkercad, because everything is essentially 2D, if I were to click my LED here, it's pretty small. So I have to be a bit careful with that. And what I'm going to do is just place my LED here. And remember, if you're following along with the breadboard basics lab, what you're going to find is you want to make sure it's connected across a row, not a column. So if I click, it'll place it. And there I am. And now it's trying to place a wire for me. If I don't want it to just yet, which I currently don't, I hit escape and it goes away. Okay, so if you accidentally say you click on a hole, you didn't want to do that, you have a wire coming around, I hit escape and it's gone. Okay, so to make an LED circuit work, the first thing I'm going to need is the LED, which I have. The next thing is a resistor. So I click over here and I type in res, which is the first thing going to come up, which is a resistor. So I click on the resistor and it's trying to place it. The only thing is I don't want it to be vertical, right? So what do? If I want it to be horizontal is I click on the R key. So if I take the R key and I click it a number of times, it's going to rotate it. That's what R means. And I can rotate it as many times as I want to whichever orientation I want. So if I'm going to do that, let's now connect the LED. I'm going to connect it in the breadboard, and you'll see it's sort of snapping to the grid of the breadboard, which is great. And I want to make sure that my resistor and my LED share a single column somewhere. And we'll learn later in the course that the actual place that the LED and resistor go, sort of whether one is on top of the other, it doesn't really make a difference. But I'm just going to follow along with the standard where you put the resistor at the bottom or the lower potential of the LED. So now I click it, this is where I want it to go, and you'll notice it's no longer following me. And now a new dialog box comes up, and this one is actually fairly important. So it has name, which is fine. I don't care too much about the name, but I do care about the resistance. And if you're building an LED circuit, typically, a kilo ohm for an LED is a bit much. So what I'm going to do instead is I'll change that to ohms. And why not call it 330, which is a very, very common LED resistance. Now, when you're following along again in that lab that I have there, I think I said to use 1Ks. Go ahead and use the 1Ks because it is what I asked for. I just wanted to show you how to change the component values. So the next thing I need to do is connect it to power. And again, I want to stay away from power for as long as I can. I don't want to power my circuit until I'm really ready and I'm really sure. And that's where I'm going to use the breadboard's rails. So what I'm going to do is I'll take from this hole here, which is connected to the longer leg of the LED, and you'll notice over here on this column here, this is called a rail actually, I have a plus, and this is where I'm going to be putting the positive end of my voltage source. So I'm going to click here to get a wire coming in. I'm going to drag to another hole in the rail I want, and I'm going to click on that, and it will make the connection. And the wire color comes up as well. So the color doesn't matter in terms of electrical conductivity. It really makes no difference. But where the wire color matters is for you to organize your circuit. As your circuits get larger, you probably want to follow a color code. A standard color code says that power or high voltage is red, and reference voltages or low voltage is ground, which is black. And then anywhere in between, if you're doing sort of connections in between, you want to stick to a consistent coloring. Sometimes you use white, sometimes yellow, whatever happens to work for you. But typically what you want to do is make sure that you are following some kind of color convention. So my color convention is that high voltage power lines are red. And then I'm going to connect this part of the LED, or the resistor, I'm sorry, to the other rail, the grounding rail or the reference rail, and I click there, and I want this one to be black. Okay. And now nothing is happening, of course, because I don't have an actual power source. So I'm going to now add a battery. So if I type in BATT, I have multiple options, and for our course's perspective, we're going to be using the 9 volt a lot. So I'm going to click on the 9 volt. Okay, so I'm just going to look at this right now, and maybe I don't want it to be in this orientation. So I could rotate it around, right? Maybe I want it to be like that, but I could also flip it using the F key. So if I click on F, then suddenly it flips it basically along the vertical. So that's another option as well, that you can flip things. The LED, sometimes you want to flip. The battery, it really doesn't make much of a difference. So if I click the battery, it's now placed in the circuit. Again, it asked me to name it. I really don't want to, so I click away. And you'll notice that Tinkercad actually follows the same convention for power and ground that I did. So we have red, which is your positive, and negative, which is black. So I'm going to make a connection from here, the negative, to my negative rail. I know that there are some tricks. For example, you should always connect your negatives first and that sort of thing. I'm not going to follow that too much, but if you want to do that, and I'm going to make sure it's black again, I want to make sure that my convention is being upheld. And I'm going to go here and drag it into the positive rail. And now suddenly everything is powered. And now I didn't set the color. What do? I click on the wire. I click on it, it comes up, says, hey, what do you want? And I say red. Okay, similarly, if I want to change, the LED, for example, I can click on it. Let's make it green. Why not, right? So I can do all that sort of stuff. Once everything is there on the circuit board, I'm allowed to change things. It's not like you've decided once when it's in and that's it. No, you can change it all you want. Okay, so the next thing I want to do is start the simulation. Lo and behold, I click on the button that says Start Simulation. When I do that, ideally the LED should turn on, and you'll see that it did, right? The LED turned on. Now, Tinkercad is actually kind of neat because it gives you warnings if something might not work in real life, but the simulator is sort of glossing over. So if I go here to what the LED says, it says the current through the LED is 20.9 milliamps, but the recommended maximum is 20 milliamps. So the recommended or the usable lifetime of the LED may be reduced. This is really helpful because if you're actually going to go and build a circuit you've designed on Tinkercad, you don't want to make these kinds of mistakes. So let's say that, okay, well, what's going to restrict that is the resistor. So I need to stop the simulation before I can change it, click on the resistor, and let's say it's going to be 500 ohms now. Okay, so I'm increasing the resistance there, and I start the simulation, I don't get the warning again. Something particularly fun with Tinkercad is you can blow up its components if you want to. So I'm going to click on this and delete the resistor. There's no longer a resistor, and I will connect the LED directly to ground. So this is now 9 volts dumping directly into an LED across wires which have extremely low resistance. And this is Tinkercad is going to complain very, very hard about this. So if I start, there we go. I blew up my LED, and it says, hey, the current through the LED is 915 milliamps. The maximum is 20 milliamps, so I'm off by, orders of magnitude too large. And so it blew up my LED, and that's what that looks like in Tinkercad. So if you're working with a Tinkercad simulation and you see those, explosion animations, that means something has gone wrong, and you're going to need to address that because it means your circuit is not built correctly. And in this course, I do promise you that if I give you a circuit diagram, it is not designed to explode. So if you build from my circuit diagrams and you see this explosion problem, something has gone wrong, or you're sort of playing around and seeing what you can do with Tinkercad, which is good too. It's always good to blow up a few LEDs to learn how not to. It is really excellent to do that in a simulator rather than with real LEDs, so I do recommend you play around with Tinkercad.